name is Guillermo
And my name is Kevin Lee.
and our project consists of a microcomputer-powered connects vehicle controlled through an Android application. So, you may be wondering what this means. Well, it's essentially just a car that is controlled through an Android application. So, our purpose was to create a remote control car that will and has the capability of understanding user input. So, basically, you push the button, let's say in this case forward, and it will move forward, and if you press backwards, it will move backwards.
So the goal of our project was to make a software application through App Inventor in order to control an Arduino board that is located in a Kinect structure.
So our basic methodology consists of starting up the application, and it asks, is the device connected to a Bluetooth device? If it is not, then you simply choose a Bluetooth device you want to connect to. And if it is, it waits for user input such as forward, left, back, or right. And with that input, it sends it to the Arduino board, and the Arduino simply executes a command of moving forward, left, back, or right.
So here are two samples of the code. The one on the left is from App Inventor, and the one on the right is from the Arduino board. So the one on the left, the first two codes are for the Bluetooth connectivity, and the other 6 are the commands for left, right, forward, backwards, and for the steering wheel to be in the center. And on the right side is all the responses from the Arduino board to all the commands that the app sent.
Some of the challenges that came about when developing this project were that having all the servos, the Arduino board, and the Bluetooth device powered was a challenge. So we had to use several batteries to maintain it constant. And also having the connectivity between the application and the Arduino was somewhat sketchy, and it was unstable at times. And here we have prepared a demo. So as you can see, here's the basic layout of the application. And I'm currently moving it left. Has full functionality of going forward and backwards.
So there are many applications for this project, so they can be applied to both military and home use. For military, it can be deployed to hard-to-reach locations or dangerous places where the soldier cannot go, and it can also be attached to cameras and sensors in order to sense the scan an area faster. It can be used for home in order to entertain the whole family, or be used as a delivery system.
So some of the improvements that we would like to implement in the future are to have an autonomous mode in which the car will essentially have sensors all around it, and according to the distance that the sensors pick up, it will be able to determine a specific path. And we also want to have a stronger chassis, basically implementing stronger materials so that the vehicle will be more stable and stronger.
So here are the 3 pictures. Each one corresponds to each version. So the one on the left is the first version, which worked fine, but we found out that it was too slow. So that led to the second version, which was to change the gearing, but then we figured out that the teeth was not grabbing each other well enough. So that led us to the version 3, which was to redesign the whole gearbox.
We'd like to thank our professors, Ryan and Kurt, our teacher fellow Shirley, and all of our TAs, Luis, Lucy, and Kelsey.
Okay, so if you were noticing in the video, you can kind of see how well the vehicle turns, right? So the award for this goes to the worst turning radius of a concept car since the Model T.